All right, here's another problem. Again, these are the three equations to convert between the thermodynamic parameters. When you're given a question, look at the two thermodynamic parameters that are present, and that's how you're going to pick the equation. So for the reaction below, I have a K value, and I'm going to use this to determine E naught. And so I'm looking for the equation that relates E naught to K. This is the equation that I use. I've got my constants over here. Remember that N is the moles of electrons transferred. I have to figure that out for each reaction because it's going to be different. How do I do that? Split it up into half reactions. Now this one is pretty complicated. We have seen something similar to this before, but this one is pretty complicated. Let me encourage you to use the E naught tables to help you split up the half reactions. Do not use the E naught tables to determine E naught, because I've taken a little bit of educational license here and it may not match the table exactly. It's all experimental anyway. Let's say somebody did this in the lab, all right? Because it clearly states use the equilibrium constant to figure out E naught, but I do have those tables at my disposal, available during the quiz, the exam. I can use it to help me figure out how to split up this half reaction. And again, we've talked about this a little bit. I'm looking for similar things. So I know that one of my half reactions involves this. And let me go look at my tables. I'm looking for MnO2 going to Mn plus 2. MnO2 going to Mn plus 2. So scroll down to my M's. All right, we were looking at this earlier. I'll get rid of that. So I'm looking at MnO2. Let's see, MnO2, I got it a couple places, going to Mn plus 2. This is my half reaction. And there it is, balanced for me. Can I copy that? I don't know if I can copy it. Nope. I should have played with this beforehand, huh? Oh, now I can delete it, but I can't copy it. Okay, so there's the half reaction that I'm looking for. I'm going to go write that out on my other page. So here we go. I had MnO2 plus 4H plus 2 electrons, doesn't matter what order as long as they're all on the left, going to Mn plus 2 plus 2H2O. You'll notice that 2H2O is there, and you'll notice the 4H plus is there, and now I know what N is. N is equal to 2. If there had been some coefficients here, I might have had to double it, that sort of thing. But there it is. Now I can double check this with my other half reaction until I get comfortable with it. My other half reaction, I've got 2Cl minus plus SbCl 4 minus going to SbCl 6. This is everything that didn't get put in the first half reaction. And if I go look at my table and scroll down to the S's, I should find it if it's here. If it's not here, if it doesn't happen to be one that's in this table, I'm just out of luck. Yep, it is not one that's in this table. And so I can't double check that half reaction with this table. If I'd chosen it to double check to start with, I would have moved on to the other half reaction. So this is a tool that you can use. There are also other half reaction tables on the internet. You're welcome to poke around the internet to look up half reactions, but you're not looking for the numerical value for the E naught because that's given in the problem, or that's what you're trying to solve for. But I could double check this in terms of saying, well, on the left-hand side, I have -3. On the right-hand side, I have -1. That means I need 2 electrons here. I'm confirming that N equals 2. So I'm just confirming that N equals 2. So now I've got my values that I need for my equation. I'm trying to solve for E naught. And so E naught equals, let me rewrite the equation, RT over NF log K. Now I'm ready to plug in numerical values. R is 8.314, that's in joules. T is 298. N we decided was 2, F is 96,500. It's also in joules, so that's going to match the joules on the 8.314. Natural log of 1.65 times 10 to the 16th. By the way, a K of 1.65 times 10 to the positive 16th means that that is spontaneous. I should get an E naught value that also indicates it's spontaneous. So now let me plug in my values. You guys double check with me. Double check. Always check my math. Divided by. I am getting an E naught value of 0. And again, you usually have some instructions. I'm going to go to 479 volts. So that will be my E naught value for that problem. If I had been given E naught and I was asked to solve for K, that would involve an inverse log, which is a little trickier. Post a question on the discussion board if you want to work one of those, and I'll make a video for that. The math is a little trickier, but the formula is the same.